The topic for today's discussion is about collections and generics. Now, these are two very important topics as far as JDK is concerned. Collections has been with Java since I think its initial version 1.1, and generics was introduced in 1.5. But over time, generics has also gained a lot of importance, and it is used very much along with collections, and that's why we have clubbed both of these topics together. So let's move ahead. So what do you mean by collections? So the collections is, again, I mean, the name itself is intuitive, right? It's plain English. So collections is when you group something together. Now here with respect to Java, it's again when grouping of objects together. And the why is that required? I mean, that's the first question which we can ask ourselves. So it is required because, say, I mean, we are writing programming, we are using a programming language, and we need to go out and implement algorithms, implement the requirements which the business gives us, and come out with a solution. All right. So for doing that, we might have to send a list of some kind of objects to maybe another method, maybe to another PC, or to code in some place else, in someone else's machine. So there are a lot of requirements like that, right? And to cater to that requirement, what do you need is that some sort of holding object structure, some sort of object, some sort of wave which can hold all this number of objects together. All right. And the thing is that this is a sort of utility. I mean, Java provides you collection APIs to cater to the number of objects which can be grouped together, called collections together. But it is not something which, I mean, is a very like something which a language has to provide, right? I mean, it is not something very essential. But again, I mean, if you look at it from a broader perspective, leaving like trying to draw parallelism with other languages, trying to draw parallelism with everything out which we have in the world, then you will see that yeah, it's very much related. And the reason for that is, say, I mean, you go and buy a TV, right, and they throw out a couple of freebies along with it and maybe some service plan. At least that's how it works in India, right? And that's true for other objects also which you buy. Now same is true with Java as well. I mean, if you just come up with a language which is say code once and deploy everywhere, there's no change, it's platform independent, with just that philosophy, uh, it might work. I mean, but if you come up with some sort of good utilities around it, I mean, that will fasten the whole process, right? I mean, that will help people to adopt this language faster, because till that time, if you see, it was the world was towards C plus plus, C hash. Nobody was using Java at that time when it got invented, right? Because I mean, it just got invented. So to adopt anything, I mean, if today someone comes and says to you that there is a language which is similar to Java, Scala, would you like to use it? I mean, their answer would be yeah, sure, but why? Because there are so many things you again have to learn. So the learning curve is there, and why to adopt. So so in collections and as such APIs, which Java bundled along with Java 1.1, was one of the reasons that it became very like adoptable in the first place itself. All right. So coming back to the topic, so collection of objects is what we have for Java. Let me show you an example. So the thing is that there are two things which you have to notice here. All right. So one is very two important interfaces. One is list interface and one is map interface. I mean, more often than not, you might be using one of these. All right. So what is a list? I mean, list, what do you do to list down certain items on which you have to work on? You go out one by one, you start giving, okay, I will go out, I'll do something, then what next? I will do this, I'll go and buy some groceries, blah blah blah. So you have number of items put down in a list, and the same thing is represented by list object which Java gives you. All right. So list is an interface, and when it is an interface, it gives you the flexibility as well to go ahead and provide your own implementations for the list interface depending upon your requirements. Right. Now, a list is something like, say, number of items, right, written one by one, and like happening in sequence one by one. So what is important here? The important is order, right? So whatever is the way in which you have inserted data is the way in which you expect it to be returned back when you're asking for it, right? So that is what what list is all about. So order is important in list, right? The second thing which is important is what? I mean, instead of like going out and going to meet, say, your friend XYZ or whoever, and then after that going out and going to buy, say, a CD drive for you, or maybe something else. So these two things are interchangeable. You can go here, you can go here, or do other steps apart from starting the first one. So you need to have a random access sort of way. So a way in which you can access the elements in the list by index. I mean, maybe the number one can be accessed, the number two can be accessed, three, four, whatever. So you need a sort of listing. All right. So order is important. Second thing is that you need APIs to access elements uh, randomly, right? I mean, whichever you want to. And these are the two important things. They are the steps, and Java provides a concrete class for this, which is an array list. Okay, so this is provided by Java. Most of the times, I mean, you will not be moving away from what collection gives you. Collection APIs give you, like, say, I personally have been using ArrayList, hash map, all right, for long time, and only in certain scenarios I have used something else, and that was for myriad of reasons, such as we had legacy code, so we are using vectors, all right, and so forth. I mean, reasons are not exactly, can say, logical, in the sense that why we do not migrate it over to an array list, because vectors and array lists are similar, right? So why don't we migrate to an array list? That's because our product doesn't support it. I mean, we need to buy a newer version of the product. That's the reason. I mean, it's plain and simple. All right. So, but otherwise, most of the times, I mean, you will be using array list, hash map, and then there is another one more interface, set, for which you have a concurrent implementation from Java, hash set. But apart from that, I mean, it's pretty much like there are a number of other classes as well. But most of your programming world, unless you're doing something extraordinary, will be revolving around these classes only. All right. So, and if you want, these are interfaces, list, map, and set. These are interfaces. If you want, you can go ahead and give your own implementation if you're not satisfied with what is out there for from the Java side. All right. Now coming back here, so an array list. Now the internal representation of data in array list, because array list is just an object, right? So it has to store data in the backend, and the way in which it stores data is that you go ahead and store data in the form of arrays. Okay, so what that means is there is continuous block of uh, data stored in the memory, right, one by one. So you have one block, then you have another block, then you have another memory block. So in this way you have contiguous memory blocks where the data is stored, and that's how data is stored for arrays. So internally, array list stores data in this array itself. All right. Now coming back to here. So this will support. Now in arrays, I mean, using particular index that you want the first one, or you want the second element, all right, or you want the maybe the 10th element now. Uh, the 11th element now. You can actually reference it using the index and do that, right? So similarly, array list, if you see, gives you that particular flexibility. So array list has a method get, all right, where if you give the get, it will give you the first one. If you give the first one, so if you give the first one, it will give you the first data, or you can give the index here, all right. So if you give the index, it essentially goes and tries to look in its internal representation, the array which it has, of like what is located at that particular index. Okay, this is how it works. So this is the data which it is looking for, what is located at this index. All right. And if you see here, since the representation is in the form of an array and it is an array list, and as we mentioned that the order is important, since the data is stored in the form of memory blocks, right, contiguous memory blocks, the order is preserved because everything is in one place. So the first element is occupying the first place, second the second place, and so forth. So the order is preserved in the way in which it is stored. All right. Not all the data, not all the collections are stored in contiguous memory blocks. All right. And but in arrays, I mean that is one of the ways in which it is implemented. I think it is guaranteed by the JVM as well that that this will not change in future. That the arrays will be stored in contiguous memory blocks, and that is the feature which array list makes use of. Okay, so this is all about an array list. Let me go back here. We'll try to write one class and see how it works. All right. Okay, so let's say I want to create classes. Say I'll go here and create a package first for say my students. So it will be a package say com dot students. All right, and do finish and go here and create a class. Say just for say I create a student class. All right, student class. Now this student class has various attributes, right? So if you go here and try to search, it has a first name, all right. It has last name. Maybe it has a student ID. For now, let's think that there are three attributes which are there, and if we go and search for generate getters, sorry, I clicked on the wrong API. Let's say if I go here and do generate getters and setters, and once I've done that, select all, click on OK, and come here. So this is the class. Now I'm writing a test class where actually what I want to do is that I want to create a list of objects, right? Because I want to transfer this data from one place to other place. So I'll go here, and when I say one place to other place, I mean like one method to the other method. So from say main method, I'm trying to call another API, all right, and that API expects a list of student objects because it has to print or do whatever. So for that reason, I mean I'm using the collections here. We'll call the class as test student. Click on main method and create it. Okay, so this it comes up. Now here I'll go and try to define say list of students. So it's like this, say new array list. All right. And if you click on Control Shift O, which essentially stands for organizing your imports, you can select whatever is missing. Now I have this, all right. Then do students, and it will give a method to add. Now you can add the object. That say my first student is. I'll create number of student objects as well. Let's say my first student name is student S1 is equal to say new student. All right. And I'll set some data there. Let's say s1 dot set student ID is 1. All right, and similarly I'll set first name, last name, but just for simplicity's sake, let's not do that. I'll add 2 students. Okay, the second one, the object is s2. All right, the student ID is 2. So I have the objects which have to be stored in the collection. So here in this collection, go and add students dot add, and then the object which here is s1. All right, and then I have s2. Now it's showing some error. Why? Because they are defined as in as string, and here I'm just passing the integers. So let's try to fix that error. All right. So here, if you see, the data is stored. Now we are done with our own collections. All right. Now see, what we have to do is that we have written a method which logs the data in the log file. So it takes up a list of student objects and prints all the details which you have regarding that student object. All right. So how to do that? One way is, I'll go here, keep on iterating over s1, s1 dot get first name, s1 dot get last name, s1 dot get student id. Similarly for s2, and then do that. I mean, for two objects, okay, fine. I mean, not required, not needed. Collections would be an overkill. But think about having thousands of students. If someone says that we need to log the details of all the student objects which comes in the request, how do you do that? I mean, if you go ahead and check the size of the students, I mean, object which is coming in, and keep on logging it one by one, I mean, it's going to be huge. And so that's why the collections is very handy. So say from here, we'll write a method here, say print student details. It will be public void print student details, and then this will be accepting a list of students. All right. So we'll come here, we will say what is like we'll check what is the size of students. All right. So int size is equal to students. Control space is going to give you the option of things which is available, size. All right. And then we will write a traditional for loop for int I is equal to 0, I less than size, then I plus plus, and then go here and print the object details. So how to get the object data? Maybe you start a new reference data type, because this is not exactly an object but just a reference data type, and this definition you can write in the starting itself so that it's not in the loop. The student s is, you just initialize it to null. Okay, and when you go here, you choose student s, and then s is equal to, say, students. All right, and you can access elements on the basis of index. So students dot get, right, and the index is what, I, because every time it has to change, and then it's gone. And for this particular student, I need to write details. And why is this giving error? Cannot convert from object to student, because get, if you see, get API always gives you object, because think from the list perspective. Now list doesn't know which object you have, whether it is students, employee, blah blah blah. It will always return you the object which you have stored in that place, but using its base class. And if you remember, all classes in one way or the other extend the object class. So the very base class, the very basic super class is being used to code these APIs, because that will be the basic class which everyone has to inherit. Other classes, not sure. I mean, I will be implementing student, employee, blah blah blah. Some scientists might be having some different classes, so it's quite different, right? So that's the reason they are using object here. So once you get an object, what you need to do is, even though it is like it's returning an object, it is an object of type whatever you stored in that particular array list or collection objects. And we stored student, so it's going to be student. So in that case, there is no difficulty. Will cast with the student class, and that means to the JVM that it automatically, that this object is the type student, and it has to automatically convert it into so. And JVM, when it sees this cast, for every object it stores the type of the instance with which that object is. All right, so it knows upfront, once you give this cast, whether it can be casted to this or not. So it checks and says, oh yeah, this is a student object, so let's return that. So that's how it works here. Okay, now once you get s, now doing a sys out, say I'll do sys dot get student id, control space is going to give the options, and then if you have other details you want to print it, you can print it. Now see, even if you have 1000 objects, this code is going to work if you call print student details. And let's call print student details from here. And this is a static method, so from static context you can't call it non-static method. So to call it, you need to have a static calling it. Okay. Now give control space, it's going to give you options. You have named it as student, so this is fine. Let's try to run this. printing 2 because I should print 1 and 2. See, 1 and 2 is there. Okay, so whatever is the detail you stored 2, it printed 2. Now say I added one, I add, well, like say maybe 10 more objects, right? And I change this name here, S2 to S3 to S4 to S5 to S6 and then say S7. So you have 7 objects. So what it has to print details of all the 7 students which is out there. Let's try to run. I mean, this is what it has to do. I'm just trying to illustrate here. Alright. Oh, actually I did not add it in the collections. It only showed 1 and 2. You actually have to add them in the collections. Alright, so S1, S2, S3, then you have S4, then you have S5, then you have S6, and finally you have S7, right? So once you have this, run it, and you must be able to see all the details regarding students which you have. And since I did not change the student ID, it's printing again 2, 2, 2, but if you print here 3, it's going to give you the answer as 3. Alright, so I'll just change 1 and show, but that's how it's going to work. Okay, so this is all about list. Now coming to the next important interface, which is a map. Now if you come to map, alright, so we come to map. What does map means? Map means some sort of way in which you can, depending on your requirement, you can find a particular value, right? So the definition of a map sort of thing is I have my requirement, and for that requirement there is a unique value. So every time you have that requirement, you always have that particular value. Think about the names. I mean, you have been listening to maps, right? Because of, I mean, it represents geographical places. Show me a map, and then you can see the places around. But if you think about this in this way, like say Google Maps, why it is named so? I mean, you have a requirement. You go and put the data. Like say I want to go to say Bangalore, or maybe I want to go to Hyderabad, and you know the specific place wherever you want to go, you put it. For that particular requirement, there is a unique value. I mean, wherever it is, right? Now this requirement is not going to change as long this value is not going to change as long as the requirement is same. That if you want to go from place X to Y, I mean the same value is going to pop up again and again, unless your place X changes to some other place, it's replaced with Z or A or B or C or whatever. So on high level, this is what map stands for. You have a requirement, there is a value, and a traditional term in programming sense to call that is you have a key, and for that particular key you have a value. So that is what a map is. So a map is an interface. It provides you APIs to store keys and values, to retrieve data using keys and values, and HashMap is one of the implementations which for the map interface. All right, and again you store data using keys and values, and then you retrieve using key or whatever way you want to. So here there is no, I mean, you can retrieve data, but it's not on the basis of index. All right, it's not on the basis of index. Data is not stored in arrays. The structure is different. I mean, it's not all the data is stored in the form of arrays. So this is what is out there. Now you store all the values in, as key value pairs inside the map which you have, and then access it, right? So what map guarantees you? Map guarantees you only one thing, that is, whenever you come with a unique key, all right, I'm going to a same result again and again. Okay, so what the map guarantees, same key, I will give you same result, and that's my promise, and that is the meaning of map interface. All right, so this is what map is all about, and one of the concrete implementations is hash map. All right, so let's come here and say the student, right? Now student, I don't want to, when I'm, this printing is fine, and it depends upon the requirement which collection objects you want to store. But say whenever you pass me a list of objects, I do not want to get retrieve using indexes, because I do not know which kind of data stored where, all right. But what I want is that for the student with the first name, say Kirti, is what I want to retrieve data for. And if that is a requirement, you have to implement in that way. So how to do that? So in this case, if you want to do that, you want to iterate over all this student objects which you have. So again, you have to do like this: get the object, then check the first name. The first name matches with whatever you want. Say in this example, I had used Kirti. Then that is the one which you have to use forward. Maybe print the details or do something else. Maybe set the marks or or whatever other attribute is there in the student's object. All right. So now to get and check for a particular student name, for say if there are like say 100,000 or say maybe 1 crore objects, that is the case, it's going to be difficult. I mean, you have to iterate one by one over all the stuff, then check for the name. If the name matches, you have found your match, right? Now this is going to take quite a significant amount of time. You have to manually do that. Now using key and value pairs, you can store data, right? So say if I have 7 objects, all right. So if I have 7 objects, so I define a map from my side where the key is student ID, or say first name, because that's what I want to use the data for. But I'll come up with something out here. But let's, for example, for simplicity's sake, let's take it first name, and on the basis of that, I need the student object. So see, if the requirement is clear that this is what you want, this is how you will store data. All right. So you have first name, you have student, and then you store all the data. And whenever you want for Kirti, what you will do, from the map will provide an interface get. All right, and there you have to pass the key. And the key in our case would be whatever first name we want, whatever is there in the object, and type Kirti. All right, and then Java, the implementation which you have for the map interface, the hash map in this case, whatever we are discussing, goes out and searches that which object you have stored for this particular key, which is Kirti, and then you find that particular object, it returns it. All right. So let's try to do that here. We will have like say another method, say with similar definition, not print all student details, just print specific student detail. All right. Print specific student detail, and this is expecting an object student instead of, no, but if you do that, you don't have the access, right? So you have the list of students. All right. Now once you have that, uh, how do you know which one to print? Maybe you want the key here, so you have two input parameters. All right. Now, and you don't have the list, you have to have the map. All right. So let's call it as map student details. So what you're going to do here is like say, and this is not going to be void, because you need the student. Oh, but we are just printing it, so void is fine. If you want to return it back to the method, this particular object, you need to actually go ahead and type here student instead of void, because this denotes a return type. Now let's come back here and why it is giving error. Map can be resolved to a type. Just click on that, it will give you the classes to import, and then import it. All right. Now coming here, student details dot get 0, or whatever is the key, in this case the name itself is key, is going to return you the data, right, which is student s is equal to. Okay, now this is again an object. This also for similar reasons returns object. So type it here, put student. Okay, now for printing you can use the same piece of code again, right? This one, because you already have the student object, so you don't need anything else. This one you can use, right? And here, when you're calling it, instead of this one you have called, but say alright. So what we are going to do is we are going to create a map, say map, and the name is student map, alright, is equal to new, and it is hash map. Alright, now say I go here student map, and Control Shift O is going to import the necessary classes to map dot put, right? Your key and value. What is the key here? We've decided that it's going to be the first name, right? So say for everywhere else I have to go and add the first name. So for simplicity's sake, let's take that we have only 3 objects. Alright, so otherwise I have to enter first name for all of them. Say for student 1 I have the student the first name is say who else we have in our class, say Julia. Alright, say then we have say Suhas. Alright, we come here and you store that detail over here, right? And for student 2 we had Kirti because that's how we wanted to get the data, right? So to put, oh sorry, not student thing got put, but oh yeah, I mean I have to set the name first, right? Set first name, and here it will be say Kirti. Alright, so once you have all these details, you have to put the key and say the key in the first place would be say Julia, which I have put. Alright, this is I'm sorry about the name mistakes, it should be Julia. And then you have the details which you want to store, which in one case is student 1. Alright, and then try to replicate it, and then you have say Kirti, and then the S2 object is there, then you have Suhas, right, and then you have S3 object. So here you have created your own map. Alright, now say I want to detail only about Kirti, so I'm calling this print specific student details method, print specific student detail method, where I'm passing the student map, right, and the key I want to pass as Kirti because this is my requirement to print for the key value Kirti. And let's see how it works. See, again it was able to find the details, and here we had only printed the first name student ID, so it printed that one. But see, another benefit of collection. So here you are only printing student. Tomorrow if you want to print the first name as well, it's very easy. I mean, you just have to add it in one common place, and for all the object structures it gets reflected. This is a very good thing about collections. So it increases sort of reusability, it increases modularity as well. See again here, if you print details about key. Alright, so this is what we have for map interface. So the concrete implementation is hash map. Now hash map is named so for a specific reason, alright, but we'll discuss about that shortly. Now let's say the third one is set. So what is there we have for set? So the thing which we have for set is again interface. Now if you think about Venn diagrams, we had sets there, remember? Like what is the common part? The common part is it has unique elements, right? So those unique elements are stored in the set, and the same thing holds true here as well. So set stores unique elements. Set is just an interface, and Java as such via hash set provides a concrete implementation for that. If we store hash set, the same stuff again and again, it's going to get it's going to get like replicate. It's going like we are going to store data, and if you have the same data being stored again and again, and it stores only one, it's not going to store it. So only once the data is going to store the data which is there for your hash set. All right. So let's say we'll create another hash set here. All right. And we will keep on adding objects, but just for simplicity's sake, the object which we'll add is say a string. Alright, we'll just leave the students out of it for now. will deal only with strings. Alright, so we will go and add, say in first case I add a string 1, alright, and keep on adding it, right. The second case I use string 2, in third case I use string 3. So now once after execution till here, the hash set has the details as 1, 2 and 3. So this is what you have for hash set, right. Now you want to print those details, alright. So if you want to print those details, I mean you have to again, I mean say uh, we'll just print here itself instead of calling a method, just for the sake of simplicity. So hash set doesn't give you, if you notice, hash set doesn't give you a direct way to retrieve details. The only way is that, I mean, you have to iterate over it. If you notice the APIs which are there about adding, clear, cloning, blah blah blah, but we don't have anything for retrieving. What we have is an iterator. Alright. So you have to use an iterator, and what does iterator means? Iterator means you are able to iterate, go one by one over all the elements. So iterator is an interface which this hash set must be implementing. Alright. And every set has a reference to it, it's iterable, and that's why we are able to add an iterator for it. And you can refer to it using, say, iterator itr object is referring to this particular iterator. Alright, and once you have this, you will be able to go one by one over all the elements. So I'll go over iterator dot has next. Alright, and if it has next, I'll pick up the elements. Alright, and here I know that whatever is stored, because it is going over set details, it's going to be of type next string, because that's what I'm storing here. So say string as is equal to, and I'll pass it using string, because that's what we are storing here. Alright, so go here, have this data, do a sysout, alright, and print s. See here, now we are printing 3, 2, 1. Whatever details went here, that's what we're printing. For now, just let's comment out and see another benefit of modularity. If you want to like stop one piece from getting executed, you just comment out or remove that method call and it works fine. Otherwise, if I wouldn't have written this in the modular way, we would have to repeat the same thing again and again, and everywhere I will have to go and modify my code. Alright, to do it. So if I just run it and see, I'm getting 3, 2, 1. So 3 to 1 is not guaranteed that if you insert in order 1 to 3, the data you're going to get from 3 to 1. This is not guaranteed, right? What is guaranteed is that you only have unique elements in a set, right? Whether it will give unique or not, it's not something which set guarantees. It's not something which hash set implementation even guarantees. So it's going 3 to 1, tomorrow it can come 2, 3, 1. I mean, there is nothing else which you can do. You can't go and say that this order has changed, because you need not depend upon this ordering. That depends upon the internal implementation and also the operating system. It's not something which JVM guarantees to you. It guarantees in the case of an array list, but not in case of hash map, not in case of hash set. Alright, so you have this detail, you have printed it, and you can try to store the same details again and see what happens. Alright. See, it only printed 3, 2, 1, right? So it stores unique elements. If you add it again, if you see the result, it will be an integer, and that's what I think. Let's see, because that's how it used to track in other places, as far as I remember. See, it's a boolean, right? So it gives you whether this element was added or not added, right? And we see it's written here, true if this set did not already contain the specified element. It is false, which means that the element was present, will not add it for you, right? So this is the basic definition between set and any other interface. Set interface guarantees you unique elements. Okay, so till now we have discussed three kinds of interfaces. We had uh, say list, sorry it became small. We had list, we had map, we had set. And the thing is that there are different kinds of interfaces, but as even an interface can extend an interface, right? So these are the second level of interfaces which we have. The first level which all of these extend is collections. Alright. So collections is interface which all of them use. This is the top level interface. Alright, and if you go and search, you can find collections here. Control Shift T in a Windows app machine, I think that works for Mac as well. It's going to list you the class files which are there in a workspace. And see, this is a very basic interface which is implemented with other interfaces, which in our case is list, map, and set. List has various concrete implementations which Java gives. The very popular one is array list. Alright, similarly for map we have hash map. Alright, and for set we have hash set. Okay, so this is what we have. Now this is for your collections. Alright, uh, let's move over to generics and see how that works. Okay, now what about generics? So generics, if we come here and see here, this whole class, if you notice one thing, it is filled with these warnings. This yellow sign which you see is warning. Alright, and why it is giving this error? This is giving an error because it says, see, list is a raw type, references to generic type list E should be parameterized. Now the reason why it is saying this is, if you see this diamond operator, right? Now this is a sign that generics is out there. And why generics is out there? Because I am using a version which is after JDK 1.5, obviously, right? Because till now the latest version is 1.8, so why to even stick with an older version? Because the newer version has newer features, right? So if that is the case, then this diamond operator is used to denote generics. But before we go out there, let's try to understand what exactly is generics. Alright, so we have generics, but what exactly is generics? So generics has, it means that making a thing generic. Alright, so you make a thing generic. A thing in Java world is nothing but objects, right? So some way or the other, I mean the classes. So in some way or the other, you try to look for like say making things generic. So let me give you an example that's going to make the things clearer more. So if you come here and see this student, print student details, right? And this is a list. Now think for a minute, this is a main class and here we are adding students one by one, right? And we are storing that in the list and then passing it here, which I have commented out because we wanted to stop the execution last time. So if that is the case, then we'll come here and see what stops you from adding, say, uh, employee here. Instead of adding student object, I add employee, right? There can be employee object which I'll also add, and there's nothing which the compiler can do to avoid, to say that this is not possible, because I mean, frankly speaking, this may be a simple example, but in complex scenarios, I mean, it's not possible. There can be like the same scenario can hold true in one case, it can hold false in one case. So you can actually go and create like have an employee object and insert that, add that in the list. All right, and then if you come here and try to print that, say get student ID, it is not there. This cast is not possible because that particular element, maybe say at the index 4, is of type employee, and that's this class cast exception is going to come in this particular location because it's not the correct class, right? So this is what's going to come out. Now to avoid that, Java thought that I know upfront that before compiling my code, that that particular collection, okay, that particular class, maybe that particular method, what does it need? All right, then why not guarantee that upfront? So came the concept about compile time safety. I need some compile time type safety, right? And I need to know that what data is stored, and I already know what data is stored in that particular collection. Then why not give the option of doing that? So that's what Java came up with, all this diamond operator. So what it is, diamond operator means that you can specify here the type of class, the data which will go in. So I'll go here and type student. Okay, all right, and this is for array list. Here I also specify that it's a type of student, and see, the error went away, the warning which was there went away. So now this is accepting only students. If you add employee, Java will give compilation error upfront. Now just for understanding, let's say instead of adding employee I add a string, because that is also an object, right? I go ahead and add say ram, right? It's not going to compile, the compilation is going to fail. The method add student and the type list student is not applicable for the argument string. It has to be student. So you can't do that class cast exception mistake because of generics, right? And this is what is called as generics, adding this parameter to make an object generic, right? And what it guarantees is compile time, type safety, right? This is what it guarantees. And similarly everywhere, so if you map the key value, you can see what this key value should be. And your key can be say string, all right, and value can be object, or maybe like you can go for a specific object, student, right? And you can put this detail on the right side as well. Student spelling is wrong. Okay, now see, this is going to solve the issue. Similarly with hash set, you can see that it wants string. Now this is what generics stands for, right? So it guarantees you compile time safety. Now say I have written a methods here, right? These methods I want that they should always be a list, should always be a list of students, not just list, because in this case, even though you're not able to add employees here, right, you can create a separate code, maybe like say down here, where you're creating another list and passing to this method. Now this method as such expects that all the list which it is getting is containing the objects of type student, but there is nothing which this method guarantees here, which it forces here that I only accept methods of this type, right? So that is the case. I mean, there are chances that if you rewrite the code and remove the generics, call it again, it will fail from here. You'll get the class cast exception here. How to avoid that? I mean, you can pass in the method parameters as well the diamond operated value, which in this case is student. In this case it guarantees. So even if one of the elements is a type object, so if one of the elements is a type object, all right, then sorry, this is a type employee, then this is going to fail. I mean, wherever you're trying to call it, that's going to fail. Okay, now say for an example, okay, so same thing here, you have to change the map. Say same thing here. Now say here, the one of the ideas is that I want to write a generic method, all right. Why do I want to write a generic method? Because I mean, I do not know what details are expected here, okay. And this is not merely say printing specific student details, but say printing specific object details. So in that case, this method is kind of overwhelming, right? Because I do not know what kind of details are going to come, and this is only going to accept a list of students. If tomorrow I have list of employees, it's going to create problems, right? And this is not going to work out. So what to do for that? So you can go here, just say like say let list t, all right, list t, and write as an example t cannot be resolved to a type, that's okay. And then, or instead of doing t, let's give like this question mark, which means that I accept any kind of object, all right, but it has to be the same type. So if that is the case, if you come here and down below And see, instead of passing students, you can pass something else as well. It might fail here because of class casting, but otherwise not. Okay, and say done here. The only thing which is going to happen because this is that you're only going to work on the base level, all right? Because I mean only on the object level. Why? Because I mean you'd never know if you have written like this question mark. Anything can be expected, right? I mean anything can be expected, like what can come, all right? So that's the reason that anything which is specific to student class, like say get student ID, get first name, has to be removed. So this is what we have for generics, where you can make a method also generic. There are ways in which you can make the class as generic. So I think you can give here like say T, all right. Then this means that wherever, like say I can use I think T here, then that is a requirement. Something else is missing. Let me check on that. Okay, I think this is because static. Alright, so if you have something of this sort, you can say list T, okay, and I think this is not well because you need it out here. So in the upfront itself from the class definition, alright, and this is coming up because of this call which was there, alright, and this is because this method was static before. I'm writing this so that it helps for reference in future as well for you. So here it comes, and then you see you can put that this class works on generic data type T. So this means that once you will define this class in the starting itself and say that it stores say maybe say student, and that is what this T stands for, all right, and then everywhere you can use this reference as T, all right, and then use that across. So this means that the test student class will always be working on type T. You have the flexibility of defining that type while creating the class itself, all right. Now if I go but you have to stick to that throughout. After that you can't change. So let's say if I go and do test student, see I have it's still giving me the option of T, all right. Test student is equal to new test student. And since Java compiler doesn't know what it stands for, give me an option, but say I want to use string, I want to store string here, I can give that reference, alright, and then use it. And this is because I'm not using it, but this is how we can define it, alright. So using this is going to give you an option of providing compile time safety. Wherever you're using this T, it will always be referring to of type string because of this particular definition, alright. So this is a high level what collections and generics are all about, and this should be pretty much sufficient for you to move forward. Let's go back to the slides which I have and see what all options are mentioned, and then we'll take it from there. Let's discuss generics first, and then we'll go back to collections. Alright, so generics, as I told you, was introduced in Java 1.5. This ensures compile time safety. You see again, we are creating a list here. This is a type linked list. And the meaning of linked list is they are linked. I mean, the language itself is very intuitive, right? So linked list means that first element, okay, just a second, let me precise. So first element in one way or the other is linked to the second element. Okay, a second element is linked to the third element. So if you want access to the second element, you can traverse from first to second. Now this type of traversing is not possible if you remember in array list because they are contiguous memory block, but they are not exactly associated. So one occupies a memory space, like say first few memory spaces, then the next few spaces are occupied by the other stuff, and so on. So that is the relationship that after first the second will come. So you, because of memory location structure, you know what's going to be coming, but not directly. I mean, first one doesn't know anything about the second one doesn't know anything about the third one or the first one. All right. So here, see, we're adding it back here, and this is what generics gives you. Like you can define that it will only store integers, and then add it out here, right? Now this is all about the definitions of list and iterator, and if you see, they're expecting a generic type E, all right? And if you use E, this will always be used, and that's the reason that if you define, say, list here, all right, list student, I define upfront. Now the definition of interfaces you saw, it is I mean, in the very basic Java source code level, it is expecting a type E, all right? So what that means is that it's going to give you a flexibility of defining what object you want at runtime. So here it's giving you the option of defining that it's of type student. But once you have fixed it, I mean, this particular list reference students, this particular object is always going to refer is always going to refer to the reference data type student only. It's not going to refer to employees. So it's a sort of, like, say, a perfect blend of like two things which you want. One is flexibility, and the other one is like compile time safety, right? So it's a perfect combination. Now this is what, and again, I mean, this is what I was going to this is what I was explaining as well. When for here, if you see test student had T, so once you define in the upfront, like while say running it, that's how it's going to work later on. Okay, similarly we have for iterator. All right, now the E in the angle bracket is a formal parameter. This E gets replaced with the respective actual parameter while invoking the method, right? And the generic type declaration is compiled only once and turned into a single file. Now all this stuff, I mean, it's not done at runtime that you're creating string and you are checking on the details, right? It's done during compilation. So when you save this file, it gets compiled, and that's why we're getting those compilation errors when we are trying to in the list of type students, we're trying to store say string, and we're getting error at that time, remember? So it was because it's ensuring compile time safety. All right, so this is what and it happens at compile time, I mean, not at runtime. It's happening at compile time. So generic type declaration compiled only once and turned into a single class file. And say this is how the print was working. I think we have discussed this. We have like rewritten the same thing again using generics. All right, and the thing is, this is what we discussed with question mark. You can use wildcards to avoid giving the exact class name in the method above. All right, so because here, say, in the collection I can use system.out.println the object itself, and the object, depending on the type which it is, I mean, I can go here, and for a student object, instead of, say, defining everywhere what I want, I can just define two string methods. So every object, it is there in the java.lang.object class, a method named as toString, and you can override it for your case, right? So you can override it and say, like say, create a string s1, all right, string s, where what you do is that string s is a combination of the objects which you have, like say this dot get first name plus this dot get last name, and in the examples which I'm not printing it, so let's not use it, get student id, all right, and then return s. All right, so instead of going and writing everywhere that I want like student id first name, I can just say print with a student. All right, so if you say like this, go here and type s. All right, so if you just go and type this one, what's going to happen is you're going to print student details. Come here, let's uncomment it. All right, so after uncommenting it, and it's doing error because of, I think I've removed the static context, right? So yeah, so we're removing static context. Let's remove the generics as of now, just for to run this method. Okay, now so this is how this is, right? And if you go ahead and run it, it's going to invoke and sys out. I mean, you can go and check, because this is at the end of the day, it's a class as well, right? So let's go and sys out and see what it prints. I mean, what expected also as well, right? So system, if you do system.out and just remove this for now and say what all you have, print. Now one of the ways is it expects a string as well, right? So you pass you pass like say your s object. So if you pass the object like this, what's this particular class which you have, say system class, and the methods inside it system.out.println does is that it prints, when it calls a toString method of the object class, right? And this one you can override for employees, student, any type of collections as well. So you don't have to change this class, I mean this particular method for any type of stuff. So you can just put like this, right? So if you do it like this, it ensures that you expect something out of it, right? A specific type. And instead of doing like say you want like say student, you just put object and printing it. So it's a very generic method which is out there. And if you print it, it's going to print the details. It's not that it's not going to print, because that some error is out there. You can see, yeah, this is because it's static, right? So let's give here static. Alright, so it's printing it out. Julia 1, Kirti 2, Suhas 3, Y. Because here I've not put in a space. If I put space, it's going to give you the extra details as well. Right? See, now it's fine. Alright, so this is what's out there for what is explained here. The genders can help in compile time checking so that the error is not introduced or discovered at runtime, right? So you get error at compilation as well, not you don't have to wait for a runtime, right? And now coming to example of generic methods, the method which I discussed here. Now say you can define what you want here. Now you define an array that is of type E, alright, and you mention here what are the generic parameters expected, alright. So if here if I expected E, that you can refer, okay, and then you have to move ahead. So if you go back and say student 1, right, so I'll remove it, okay, and this will give error. So let's comment it out, and I go here and I have put list T. T means just a type. I mean, just a way to say that this is one type, and that type will be decided later. And I think you can, after static, you can give, I guess. See, so here whatever you have given shows the types which are expected, the types which will be processed or maybe returned from this particular method, and then wherever you want you can refer the type. So if it is instead of void, it's returning say another type, say E, alright. So you can mention it like this, but again you have to mention the type which is expected in this particular method, like this, alright. And this is saying error because since you've defined here, it is expecting you to return a result of type E, which you're not doing, alright. And say if in our case like what will be the uh, so you can go here and return something of type E, like say return E, and then I do say size, alright. So it's always going to return me that particular data, and I'll just remove it because that is found at compile time. No, I mean let's define it. So say I want to define an object E, and this is what I'm trying to return here, okay. Object E, and the detail is I want to return say object S back, alright. And this is just for an example, I just want to return S back. So you can go ahead and add this one as well, sorry, return object the object doesn't have that one, right? Let's put it like this. But you can put E here because that is the one which we are using, right? And then returning. Now see, now this compiles. Why? Because it is expecting that we return the data of type E, and that we've defined here. When we've defined type E type and returned it, the compilation will prevent away. So this is the type of like you can like fix your method. You can introduce a lot of checks around it. So you can also control the return type, that it has to be of this specific particular type. Alright, so all these things are guaranteed because of this. Now, this is what is being discussed here. The second type is example of bounded type parameter, which essentially means that you'll be able to see what data has to go here. So here in this particular maximum 345, here see this you have defined that you'll always expect values of type t, all right, and this t will be decided only at runtime. So here it is of type integer, here it is of type float, but whatever it is, I mean whether it's a float or integer or whatever, one it can change, but it has to be same for that particular, like once defined it has to be same. So this is what bounded type parameter means. I mean here also once we did and went here and said that list has to be of type say student, we have introduced a sort of bounding, right? So whatever data has to be stored is only of the type student. Okay. Now coming here, a generic class declaration looks like a non-generic class declaration, except that the class name is followed by type parameter section, diamond operator, and t. As to the generic methods, the type parameter section of a generic class can have one or more type parameters separated by commas. So at the class level, like if you go here, it's not that you have to introduce only one, as I had done earlier. Like not only one, you can just mention apart from t, anything else which you want. It's just referring to a type. All right. So that you can go ahead and introduce. So as a generic methods, the type parameter section of a generic class can have one or more type parameters separated by commas. These classes are known as parameterized classes or parameterized types because they accept one or more parameters. For example, generic classes again same. It's a box. It expects t. T becomes it has one of the specific attributes and it's of type t. Then you have methods around it, right? And if you think list implementations are a list or maybe map implementations, they'll be working on these abstract types itself because they do not know whether they're going to store students of type objects of type student or employee or whatever, right? And then if you come here, you're storing the details here in integer box. You're storing only integers. String box, because this definition you're only storing strings and then going to print it out. This is what about generic classes. All right. So this is what we have for generics. So coming back to collections. All right. So coming back to collections, so number of objects of the same type and grouped together. There are many scenarios in the real world, such as say passing number of employees from one method to the other method. We also discussed one scenario in the examples which I was giving. The language does not provide a way to group the objects together. You have to find a solution for this, but luckily Java provides it, and it's from 1.1 itself. And after 1.5 version, it has come integrated along with generics. Okay, and see, this is a collection interface which I was talking about. It is implemented by set, list. Map is also a sort of collection itself, which is mentioned here. Then you have queue, and then this set interface is implemented by sorted set, and the collection is a root element, and the other elements extend from it, and that is what is mentioned here. All right, and then this is a collection interface definition. So if tomorrow if list, map, etc. do not satisfy your requirements, you want to create another level of an interface, you know what all methods you already get from here, whether it's empty or not, contains, add, remove, blah blah blah, and then maybe extend it or write your own, right? An iterator is an object, and an iterator we discussed, right? That iterator iterates over a set of objects. Remember we discussed it with reference to set interface, because set at that time it doesn't give you direct relationship, it doesn't give you direct access to the indexes. So to find a particular object, you have to iterate over it. Okay. Now coming over set, this is what we discussed. We discussed about set, list, then queue is nothing but it's a collection, it's an interface, it's a collection used to hold multiple elements prior to processing. Alright, so queue is basically like what it stands for. I mean, you're storing the objects in the form of a queue, and then you have methods defined to take one element out of it, to put one element into it. It can, like whenever you have to get one element out of it, it is only from the start of the collection. Whenever you have to whenever you have to add anything, it has to be towards the end of the collection. Whenever you have to get something, it has to be from the start of the collection. And once you do a start, I mean that element is automatically removed from the collection. Why? Because that is what queue is. When you take one element out of it, I mean the element is automatically removed. So to have that sort of logic, to implement that sort of requirement, we have a queue interface. All right, this is not very common, but in specific scenarios, multi-threading, etc., you might need it, and that's why I have put the definition here. We discussed about map as well. Then this is a map interface. We have put, get, remove, and contains key as well. So the other methods are defined here. Then the list and hash map, array list and hash map we discussed. All right, and this is what is mentioned here. What are the different implementations? Hash set, array list, hash map, then linked list we discussed, right? So these are some of the popular general purpose implementations which we have to know about. Okay, and then we discussed about generics. So this is what we have for for collections and generics. All right. Apart from this, there are a number of questions which are towards the end. For this time, since it's a weekend, I mean the number of questions are more. I think it's around 14 or 15. There are some theoretical questions as well at the top. I'll request you to please go through them as well, because I mean obviously I mean map is a very vast course, so there are a number of items apart from that, and there are a number of clarifications you might require. So those theoretical questions will help you to get there as quickly as possible. All right, so this is what I had for collections. If you have any questions, you can ask me, otherwise we can disperse. Any questions? Okay, guys, thanks for your participation. If you have any questions, or if you want to turn out your assignments, please mail back to me. I'm holding back discussing about the assignments because I want most of the people to participate, and that's how it's going to help all of you. Okay, so if you want to discuss all the assignment questions in the class, it's better that you actually turn out in huge numbers and do all of it. I mean, one or two people going out, I mean, I can help them individually if they have problems, but discussing it in the class will not be possible because it's taking time out for people who have already spent doing it, and then it's like it's not helping others because they have not done it yet. They might do it in future, and I do not want to provide the details upfront. But anyways, thanks for participation, and if you have any questions or any doubts, please mail me back. That's how we disperse. Have a happy weekend.